How to make a manometer. So what is a manometer? Well, it's an instrument used to measure pressure and vacuum. In this example, it's used to measure vacuum with reference to atmospheric pressure. The units are centimeters of water, H2O. You can have inches of mercury is another common one. Inches of water is another one. This one is going to be for centimeters of water. It's a simple loop concept. We use a loop of clear tubing. So we have a loop here of clear tubing, comes down here, loops all the way up. One side is open to the atmosphere, that's this side. The other side is connected to the device that's under the test. Vacuum is going to pull the liquid. This is our water. It's going to pull it up. And what will happen, atmospheric pressure is going to push it down. So one side pushes, the other side pulls. The tube is going to be marked in centimeters in my case. So if we read a measurement, this is the important concept. So when the vacuum side goes up 1 centimeter, what we'll find is the pressure side will go down 1 centimeter. And what we do is we measure the difference between the two sides. So the difference would be 2 centimeters of water. So one vacuum goes up 1 centimeter, atmospheric side goes down 1 centimeter. The difference is 1 plus 1 is 2. Here's an example. What I have is, here's my reference point here. And what we do is if we count the centimeters, 1, 2, 3, 4, 5, 6, 7, 8, 9. The vacuum has moved up 9 centimeters, and if we look at the pressure, it's moved down 9 centimeters. So the difference between the top of this water on the vacuum side and the bottom of this one here is 18 centimeters. So we would have 18 centimeters of water vacuum. Let's do another example. Example number 2. If we count here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the water has been pulled up by the vacuum by 11 centimeters, and it's been pushed down by the pressure of 11 centimeters. The total vacuum is 22 centimeters of water. Easy way to do it is just to multiply the vacuum side, right? So it's always even. So if it goes up 11 centimeters times 2, it's 22 centimeters. The supplies you need is a backing board. I used a 1x4 inch board. The length depends on the maximum vacuum that you require. In this example, the requirement is to measure 80 centimeters of water. So I need a manometer that is at least 80 centimeters long. I need room for 40 centimeters to go up. This is my vacuum side, 40 centimeters to go this direction, and then 40 centimeters to go this one. So a total of 80 centimeters, 40 plus 40. I used a board that would fit a 100 centimeter manometer, and that gives me a little bit of room here. So when it gets up to 40, I still have 10 centimeters here. There's 50 on either side, and the same down here. Also, you need a room for a loop, right? So the overall board has to have 100 centimeters in this case, plus room for a loop, and a little bit at the top for your hosing at the top. Any clear hose will work. Basically, you select the inner diameter based on the fittings. In my case, my fittings, I needed a 1/2 inch was my fittings, so I used a 1/2 inch inner diameter hose, ID, and I got a hose that was 20 feet long. Normal sizes for hoses is 10 feet and 20 feet from what I found, right? You can pick these up at any home hardware place or hardware supply store, plumbing, whatever. And they're not expensive at all. The clamps should fit the hose outer diameter. I think my hose, it might even say here, it says 1/2 inch by 5/8 outer diameter. And this happened to be, it fit pipe clamps, copper pipe clamps that were for copper water pipes, and so, and that. When you clamp the hose, you have guide hoses, guide hose clamps here. These guys are for guiding the hose up, and you have a top and bottom one. I put one in the middle just to keep everything aligned, and then also I put another hose clamp in the center of the loop, and it keeps the loop clear and open. Otherwise, what would happen is the hose would crimp. It would come straight down and would get a crimp here, so I just put a clamp in here to get a nice loop on it. Mark the hose. I used a permanent marker and marked the hose in the units you're measuring. I'm measuring in centimeters, so I just took a permanent marker and marked one of the hoses. This was a vacuum side every centimeter. So then I marked the hose using a meter stick, complete length 100 centimeters. This could easily be marked using inches too if you needed inches. I added a hanger clip at the top, so basically I took a metal clothes hanger and I rebent it and formed it to make a little hanging on here, so that I can hang it on the door or anything up high, because this is a normal operation, it's in vertical mode. I added food coloring to the water, so water is clear. It's difficult to see clear water in a clear hose, so I just got raided the pantry, got some blue food coloring and put it in there. I got a nice blue water. Filled the manometer up on the atmospheric side, so I just use a little funnel, filled it up, and I filled it up to my 50 centimeter mark, and then I added a little piece of tape here so that it's easy to see, right? And that allows you can move your mark up and down depending on where you want it, right? So this is my reference level, and you'll see that they're both even, right? The water is even. So this allows the pressure side to rise, the vacuum side to rise up 50 centimeters, and the pressure side to be pushed down to another 50 centimeters. Now basically it's ready to measure, right? So I hook this up to my device under test, apply vacuum to it, and what we'll see is this will start rising and this will start lowering, and the difference between is the pressure. And that's basically how you make a manometer.